Hello and welcome to 12.5 Notes. You may recall from 12.4 Notes that we went over the volume of prisms and cylinders. And again, in 12.4, we discussed the formula for the volume of prisms and cylinders, which is that the area of the base times the height of the whole entire three-dimensional figure is the volume of that prism or cylinder. Okay? But today's lesson is on the volume of pyramids and cones. So let me just do this here to review the relationship between a prism and a pyramid, and also the relationship between a cylinder and a cone. So you may remember, again, this is a review. A prism has the same figure on both bases, right? So this would be a square bottom and a square top. In other words, both bases are squares. Okay, so that's the definition of a prism. A pyramid, however, would have a square base, but it meets at a point on the other side, on the top of it. Okay, or it just has one base, a square, and then the other side meets at a point. That's a pyramid, and they're related. If the area of the base is the same, there's a relationship. We'll go over that in just a moment, but I just wanted to give you a quick review of what a pyramid is, and then also a cylinder versus a cone. So a cylinder, okay, and that's a prism, and I should probably write that that's a pyramid. Okay, and a cylinder has a circular base and another circular base. That's what makes it a cylinder. Okay, but a cone has a circular base on one side, but then the other side meets at a point, and that would be a cone. And if the area of the two circles are equal, then there's also a relationship between a cone and a cylinder. Okay, so today's topic is going to be, here I'll do it in red, is going to be on the volume of a cone and the volume of a pyramid. Okay, so let me erase those two really quickly. Give me a moment, please. And bear with me. So what is the formula for the volume of a pyramid and the volume of a cone? Well, the formula for the volume of a pyramid is 1/3 the area of the base times the height of the whole figure, and the volume of a cone is the same. It's the volume, or the area rather, of the base multiplied by the height of the whole figure, and then multiplied by 1/3. So the relationship between the volume of prisms and cylinders versus pyramids and cones is, well, the formula, as you can see, is exactly the same. You just have this 1/3. So if the base has the same area, then for a prism and cylinder, you just go base times height. But for a prism and cone, you have to multiply by 1/3 or divide by 3. And that's because you can fit, as you can see here, you can fit 3 cones inside of one cylinder, right? So if this was a cylinder with this area of a circle and that area of a circle, you could see that you could fit 1, 2, and 3 cones inside that one cylinder. Okay, so when you come to class tomorrow, or in class, I'll go over another demonstration that I think will point this out much more clearly. But for now, that'll have to suffice. And remember that what you're learning now is the formula for the volume of a pyramid is 1/3 area of the base, okay, times the height of the whole figure, and the same thing for a cone, area of the base times the height of the whole figure multiplied by 1/3. So this is what you're responsible for today. So please write this all down and get caught up. And remember, like usual, you're in total control of this presentation. You can pause it, fast forward it, do whatever you like. Again, you're in total control of this presentation. So you may pause it right now or at any point if you wish. But for sake of this presentation, I will continue. So again, these are the formulas that you'll be responsible for. And what kinds of problems could you possibly get based on these formulas? Well, here's a problem that has to do with pyramids, okay? So, find the volume of a regular hexagonal pyramid with side length 4 yards and height equals 11 yards, okay? So, this is a regular hexagonal pyramid, so the base is a regular hexagon. That means that all the sides are congruent, right? And each side length is 4 yards, and the whole entire pyramid, in other words, if you were able, say for example, to stand in the center of the three-dimensional figure and look up, the height would be 11 yards. Okay, so let's work on the answer here. Let's start with the formula. The formula is 1/3 area of the base times height. Okay, so let me go back here. 1/3 area of the base times height. And 1/3 obviously remains 1/3. The height of this figure is 11, okay, that we get from here. But we don't know the area of the base. Okay, we're not given, it wasn't explicitly given, so we're going to have to figure out the area of the base, okay? Now we need to calculate the area of the base B. This is now chapter 11 stuff, right? It's going to be the area of the hexagon, of this two-dimensional hexagon. So this is just a quick review. I'll do this kind of quickly since we've already completed this chapter. But the area of the hexagon, remember, is 1/2 ASN, where A is the apothem, S is the side length, and N is the number of sides. So we have this hexagon here, and it could basically be broken up into 6 triangles, and this blue line segment is the apothem, and we weren't even given that length either. We were only given that the side length is 4 yards. So we're going to have to use trigonometry or SOHCAHTOA to figure out the length of this line segment or the length of the apothem. Okay, so if I travel around this whole figure, that's 360 degrees, right, traveling in a circle, and there are 6 of these triangles, right, so there are 6 of these angles in a sense around here. Remember we went over this in chapter 11, and so each degree measure is 60 degrees. So bear with me here. So this angle here is 60 degrees, okay? And what I'm going to do now is take this right triangle only, and I'm going to blow it up. And again, if that angle was 60 degrees, then this angle must be 30 degrees. This is 90 degrees, and so this must be a 30, 60, 90 degree triangle. And we are given that the side length is 4 yards, but remember this triangle, it was cut in half, right? Because it's based on this triangle here is cut in half. So this length is 2, and then using what we know about 30, 60, 90 triangles, then the longer leg must be √3 times as long, right? 2 √3. Also, what you could do right now, if you'd like, is you could pause this presentation and use some trigonometry. Just do SOHCAHTOA and do the tangent of 30 degrees is equal to 2 over A, where A is the apothem. And hopefully you'll get 2 √3. So again, you can pause this presentation you'd like and check yourself, make sure you get 2 √3. But I did it here based on the fact that this is a 30, 60, 90 triangle. So I can take that 2 √3, I finally know it now, because even the apothem wasn't given, right? And I could plug that in for my A now, my apothem. And so then we have this equation is just moved over here, okay? and I have that the area of the hexagon is 1/2. I now know my apothem is 2 root 3, side length is 4, and there are 6 sides in a hexagon. So you just multiply all these numbers out, and you get that the area of a hexagon is 24 root 3, okay? I'm going to leave it in radical form. So now I know the area of the hexagon, which is the area of my base, right? Area of my base. This is a regular hexagonal pyramid, and I now know the area of the base, so I can plug that in for area of the base, and finally I get my final formula, which was really my original formula. It's just that this was sort of a difficult problem because not everything was explicitly given. You had to be kind of clever and figure out other variables or other quantities rather that you needed. So we have 1/3. Area of the base now is 24 root 3, and the height of the whole entire figure is 11. Multiplying all those out, and you get 88 root 3 cubic yards. 88 root 3 cubic yards, or multiplying that out using your calculator, you get about 152.42 cubic yards. Okay? Okay, and our final problem is find the volume of a right cone with radius equals 5 meters and slant height equals 8 meters. Okay, so copy down this prompt, please. And we have this cone. Again, the radius is 5 meters. And the slant height is 8 meters. Okay, slant height is 8 meters. In other words, we were not given the height of the whole entire figure. And, of course, that is necessary for the volume of a cone. So we're probably going to have to figure that one out. Okay, so not everything that we needed is explicitly given. We're going to have to figure out the height of the whole entire figure. Anyway, so let's continue working on this problem. So the formula is the volume of a cone is equal to 1/3 area of the base times the height of the whole figure. Okay, and the area of the base, since it's a cone, is a circle, and the formula for the area of this circle is pi r squared, right? Area of a circle is pi r squared. So that's where you get this from. Pi times the radius is 5. So we have 5 squared times pi, or 25 pi, would be the area of this circle. And 1/3 is part of the formula, but again, we don't know the height of this figure. But we can see that this forms a right triangle, so we can use the Pythagorean theorem to find out the height. Okay, hold on here. We can use the Pythagorean theorem to find out the height. So we have h squared plus 5 squared is equal to the hypotenuse squared. So h squared plus 5 squared is equal to 8 squared. Or h squared is equal to 64 minus 25, right? Because 8 squared is 64. 5 squared is 25. And you subtract both sides by 25, and you get h squared is equal to 64 minus 25, or h squared is equal to 39. You take the square root of both sides, and you get h is equal to root 39. Okay, I'll just keep it in radical form. Root 39, I now can plug into my h. Okay, so now I do know the height of the figure is root 39. So then you multiply that all out. You get 1/3 times 25 pi times root 39, and then using your calculator, you get that it equals approximately 163.49 cubic meters. Okay, that's the end of the notes. And as usual, if you have any questions or concerns, please feel free to contact me at your convenience, and I would love to help you. Okay, bye-bye.